In this video, we're going to talk about the beginning of Chapter 8, which is a culmination of all the concepts of naming and compounds we've talked about in Chapters 6 and 7. This video is going to cover Section 8.1 and part of Section 8.2. And so in order for us to understand how chemical equations are written, we need to know the shorthand we use. And this is going to be a way for us to summarize a reaction and understand how much or which compounds are consumed or produced. So let's talk about how these reactions are set up. In order for us to understand what's happening in reactions, we need to make sure we understand our reactants are going to be our substances that are consumed during the reaction, and our products are going to be our substances formed during the reaction. So you can see here in blue and red, we have our blue reactants and our red products. Notice our lowercase letters in front of our uppercase letters are going to be coefficients, similar to what we talk about with subscripts of reactions. Instead of subscripts talking about individual atoms, we're going to use our coefficients to explain completely multiples of compounds. And so what we know is that we have to have all our atoms, n number of them, equal on our reactant side and our product side. So if we see 5 atoms of oxygen on our left-hand side, our reactant side, we need to account for them on our product side. So we're going to separate our reactants and products by an arrow, and we must remember that our lowercase letters in this case always have to be whole numbers. There are a couple shorthands that we use to add. So we also add our letters identifying what state of matter. So we can see we have a solid and liquid, and yielding a gas and a solid. And so these are our shorthands that you'll need to be familiar with. We have our arrow, our symbols for our different states of matter, aqueous, which we talked about in the last chapter with acids, as well as our little triangle, which is our delta sign, which means heat is added. So one of the laws that we need to remember when talking about equations is that we know that the total mass of our reactants needs to equal our total mass of products. So in any chemical reaction, our mass needs to equal one another. And this will be important for things we talk about at the end of this chapter as well as in chapter 9. But just remember this as the law of conservation of mass. There's no way for us to destroy mass. It must be accounted for by some other means. So let's get some practice working on these. So write the balanced chemical equation for when magnesium metal undergoes combustion to produce magnesium oxide. And so this is going to rely on us getting a lot of information from our naming chapter 6, in order for us to make sure we're writing the correct names for metals, elements, and compounds. And so in this case, we know magnesium metal is going to be Mg. When we have the word combustion in a reaction, we know that this needs oxygen. And now the last part, we know that these two elements are going to combine to create magnesium oxide. So we need to look at our periodic table, identify the groups of these two elements, and understand what ratio they would need to be in order to make a compound. So we can pick out our words, and we know here magnesium plus oxygen yields magnesium oxide. So when we write the unbalanced equation, and video 2 is going to talk about balancing these, we're going to write Mg plus O2 yields MgO. And we know oxygen is one of our 7 diatomic elements. MgO, magnesium, is plus 2, oxygen minus 2, so we know that those will pair up together, no subscripts needed. We will talk about how there's a little bit more work to balance this in the next video. Let's go through another reaction. In this one, we're looking at the decomposition of potassium chlorate upon heating to give oxygen and potassium chloride. Take a moment and try to work through these. What formulas for all of these compounds? Pause the video now. Okay, potassium chlorate is going to be KClO3, yields KCl, potassium chloride, again matching up group 1 and group 7, and we need to remember what we have to have oxygen, and again, as our diatomic element. And again, the next video we will talk about how to keep track of our oxygens. Notice we have 3 on the left and 2 on the right, and that violates our law of the conservation of mass. So we'll continue to talk about this. That's the end of video 1.